Hey guys, it's Jason from the Dental Equipment Repair channel. Today I'm actually here on a Saturday taking care of a dental compressor that has a problem. This particular compressor is a mid-mark power air compressor, and the particular issue that we're running into is that there's some sort of an air leak down here around the pressure switch area, and that the compressor is running non-stop until the over temperature sensors are telling the motor to stop running because they're too hot. So these are oilless compressor heads, and one of the advantages of oilless is that they don't have any oil to get messy. They're not messy, but the disadvantage is that they run hotter, and they're also maybe a little bit louder than oil compressors. So what happens is, because there's a leak, it can't build pressure, it won't get to a point where it stops. And then what happens is, because these guys are running so much, they get hot up here, and there's some sort of a temperature sensor probably up in here. I think this might actually be the temperature sensor wire right here. And it gets hot right down there against the motor head. And then once that gets above a certain temperature, it opens a switch, and then it won't run again until it gets cold enough to turn on. So that's how come a symptom with this would just be running, and then it would get to the point where it's too hot. Then the motors would randomly kick off, one or both, and then you would end up with a situation where the pressure to the office would probably begin to fluctuate. And the way that you would know that there's a problem is if the compressor sounds funny, one motor running, randomly not running. The other thing is if it's always running. And a way that you can know if the compressors are properly working, especially when it's quiet like this, is if you touch the compressor head carefully, like this head is cold. And then I would touch this one, this head is cold. Well, the compressor's off right now, but I can tell you that if the compressor was on and this one was hot or this one was cold, I would know which motor was working or not working, even when the compressor's not on. Because in a normal situation, the compressor should be quiet, except for when the pressure is building from 80 to 100, and it basically, the pressure would go in the morning, it goes from 0 to 120 or 100 or 110, whatever it is, and then it goes down to 80 and 85, and then it turns back on. So during the day, you have kind of just this little pattern. And so for a compressor, when it deviates from the pattern, that's how we know I have a problem. So today what we're gonna do is, I brought a repair kit here. The specific issue that I was confronted with was, hey, there's a bad part, it's shipped in, and the part isn't here yet. But what we do is we actually cannibalize other compressors. So this is the same type of compressor, exactly the same. And so we actually pulled a part off of this one, which happens to have the part that was there. So as an independent repair company, we have these parts on the shelf, and that is an advantage. So if you have a dental repair or a dental office and you have independents in your area, they might be able to do things that big companies can't. So we're gonna dive into this repair, we're gonna check it out, we're gonna see what's going on, then we're also gonna go ahead and replace the parts. And so I'll just bring you along for this journey. All right, guys, there's a couple things I want to point out about this compressor. The first one here is that there's an hour meter. This hour meter is 629.7 hours. What that should represent is how many hours the compressor has been running, like actually running. So the compressor naturally is turned on for 8 hours a day, but it's actually the time that the motor's been running that captures. Also, there's a fuse holder here. If this is for the low voltage, which is right here. The low voltage is a way of turning the compressor on from a different remote location. And then up here, or down here, there's information, the serial number, model number of the compressor. That's important to know. And then also down here, there should be a metal plate, which is maybe on the back of the compressor, but it's a square metal plate, and what I'll do is I will take a picture of it and input it in the video right here, and that is going to tell us what the actual year is. And I'll just put a little annotation right here that you can read right now that will say, that'll point to it and tell you what the age is. So if you have a compressor, you don't know how old it is, that's a good way to know. So for right now, we're gonna go ahead and kick it on and see what she does. And we're expecting to have the problem be right down here with the pressure switch, because that's what was described. And we'll see what goes on. So we will turn on the compressor. And actually, first, before I do that, I'm going to reveal the box here. Now, I would say don't do this unless you know what you're doing. This box is going to show the underside of the pressure switch, which is important for troubleshooting to see what's going on in there. There's 4 screws that hold this on. Now, for some reason, Midmark, I don't know why, but they actually put switches inside the box. And what you're gonna see is switches up here. And I don't know why they wouldn't give users access to this. It's always a little design that's bothered me, but I guess if you ever have a motor that doesn't turn on, this might actually be something that you have to do in order to make the unit turn on. So I'll show you here once this 4 switches on. Now, I would also say that this actually is something where we're treading into service work versus user repairs. And the reason for that is because the difference between what a user can do and a service tech can do is a tool. So tools and training are really, so if you get shown how to do this by somebody, then I would say you're good to do it. So there's the tool, and we'll pull that off. And like I said, there's the 2 pressure, the 2 motors switches. So what that would mean is that if, like, say this motor had a problem, it exploded, you could go ahead and flip that motor off in order to run the system without it. Now, the pressure switch down here is looks fine mechanically. There's a little hose down here, and the way the pressure switch is hooked in, there's a basically electrical connection right there, and so that's what physically holds it in place. So and then the hose that comes through here from the tank pressure comes through this hose onto the back of the pressure switch. So we'll go ahead and run it. We'll see if we can confirm where the sound is coming from, and it should be pretty obvious.
All right, I'll go run.
All right, we're gonna go ahead and turn on the compressor right now. Okay. Oh. So we can see that by turning that switch off, that head didn't run. All right, I think I can start the... I can feel the pressure switch leaking right here. Alright, so we can go ahead and turn off the compressor. I can hear it leaking right here. Alright, now, since I have this part, what I can tell you is that the pressure switch is leaking from around this diaphragm, which is really interesting because this is the second time in about 3 business days that I've had this problem happen. So you can hear it leaking right now. So what I'm going to do is I'm going to make an attempt to tighten this diaphragm to see if we can improve it. Now we'll probably still replace this if I can't make it perfectly quiet, but if I can, then we'll be able to make a decision with the client what to do. But for right now, I think if we try to tighten these, I'm curious if that's going to affect it. So let's go ahead and make that attempt just for the sake of learning and because it's not going to take a bunch of time. Now to access this, right now you can tell that it's kind of not pointed in a good direction. So because this is anchored right here, I can go ahead and rotate the pressure switch. So I'm gonna just pull this and I'm gonna just rotate the whole thing to where I can see what's going on. And now I can feel the air is coming out right here, and I can even hear it with my finger. So now that I've revealed that I can just put a screwdriver and put a little turn on it. Okay? And then I can try to just go around and see how many of these I can tighten. Because if I can tighten this, that is gonna be a pretty interesting scenario. Because that's gonna mean that I came all the way up here to do something that somebody else could have done on a prior visit, 2 prior visits. And this is also something that I think is one of the ways I get to blow my own mind every day. And this is why I love my job, guys. This is why you're tuned into the right place. And this is how come this is, did you just see that? Did you just see that? Guys, that's pretty awesome. I'm really thankful for this client that gave me an opportunity to video this and capture this. These are the types of things, guys, that I want to show you how to do, because this right here, this is real as life. A tool that could help you not lose production, to not have your stuff die. So, guys, I think let's go and turn this on and see if it makes pressure. It's going up. It's going to stop at 100. Yep. So what happens is when you turn it on first thing, it's going to go from 0 to it's going to go to 80 or to 100, and then it's going to stop. And then you're going to use your hand pieces, and then it's going to go from 100. It's going to bleed down to 80, and then turn back on. So you're going to have kind of just this sine wave, where it goes from 0, and then just throughout the day you're gonna have patterns. So now we're all right. So now we're there. Now what I can see is that it's only up to 100. So we're gonna need to go ahead and adjust it so the pressure. It's actually like 95. So the way that we adjust this is there's a green screw right here. Now, one thing to keep in mind is this is dangerous right here, okay? Right here, there's power there, because what happens is when the pressure activates, it closes those contacts. So what I'm gonna do is I'm gonna go ahead and carefully tighten this, which should make that pressure go up higher when we bleed it off. So I'm gonna go ahead and tighten that down. Now there are instructions for these, and I don't want to advise anybody to go against instructions, but I'm gonna tighten this down, which is gonna make the pressure go higher, which is what we need. So I'm just gonna go ahead and maybe turn it a couple times, maybe get like one full turn on it. And we turn, and see, that's completely quiet, so we're okay. So right now we're sitting at about 90 pounds of pressure, and we're gonna see where it kicks on by opening this. Now it's gonna be a loud burst of air, but I'm gonna try to keep control over this to kind of, this is a pressure relief valve, and we're gonna use that to get down to see where it turns on. I'm expecting it to be 85, so I'm just gonna get down here and see. Okay, so we turned on at about maybe 78, so I'm gonna turn that a little bit more, because we definitely want that to be, 85 to 105, because most dental handpieces need to have a minimum of 80 pounds of pressure going into the unit And so right now we're still at about like high 90s there. So I'm gonna go ahead and put another turn on there. And so because these pressure switches have about a 20 PSI or pound per square inch range on them. So I'm gonna tighten that a little bit more, give it a little taparoo, and then here, we'll try that one more time. We'll see if it turns on over 80. We just want the number to be over 80 when it kicks in. Okay, we're closer, but we're not quite there yet. And you can kind of see how that works. Like right now, that's engaged. Now, what's really happening is one side is connecting to the other side. So the outside is connecting to the inside. See how that moves? So yeah, so power will come in on the outside, and then that little piece right there that moves is unifying everything together. So we'll try to tighten that a little bit more. And I'm just kind of going slow with this because this isn't something you really want to rush just for safety. And also too, it's best to make small adjustments so you don't like majorly mess something up. Like at the end, you might take it in 5 times or something, but you want to make sure that you're not like doing a huge adjustment and then like ending up in a crazy spot. So right now we want to be at over 80 and over 100 there. So let's go ahead and try it one more time. Right there, boom. That was at about 82. And we're gonna see if it stops at over 100. If it does, I could go a little bit higher. But if it's over 100, I think I'm just gonna leave it. All right, that's like, I'm gonna go just maybe one more turn and call it a day. All right, so we'll go just one more turn, taparoo. Now what I'm expecting is close to 85 to 105. If that happens, I'm gonna be happy. Boom. All right, there we go. That was nice and close to 85. And that one should be close to 105. Boom. Okay, so I'm super happy with how that's running now. I'm really happy with how the compressor's working. Something to talk about is when you have a compressor that you're working with on a daily basis, one thing to understand is that the compressor should run a set amount of time. It shouldn't deviate when you're running. Like when it hits that 85, it should pump up in a certain amount of time. And so what I do on preventive maintenance is I time that. And so from 85 to 105, it should be like 35 seconds or 30 seconds. Like it should be a set amount of time. So what you'll notice is, because all you have to do is listen for when it turns on, set the timer, and then when it stops, that gives you a health assessment of your compressor. Because if one motor isn't working, then that's gonna take longer to pump up, because these are like horses, you know, if one horse dies, the other horse can't pull the buggy. So I'll show you that right now. Like for this particular office, I'm gonna tell my client what, so I'm just gonna open up my timer here, and then I'm just gonna do the stopwatch, and I don't know why, there we go. And I'm just gonna reset that. So now what's gonna happen is I'm going to get it to turn on, and then I'm gonna hit start. So here we go. So I'm gonna go right here. Boom, okay. It started over 80, which is what I want. All right, so we're at 25 seconds, which means every time this compressor turns on, now there might be maybe a high-speed handpiece running or something, but if it takes like within like 15 seconds of that, I would say it's okay. But in general, with nothing going on, 25 seconds is a good indicator. So with one motor that doesn't work, it's going to take a different amount of time. Now, I feel like for time here, I'm almost to the edge where I got to go do something else, but I feel like I just want to show you what this would look like if there was a problem. Imagine that this head wasn't working, all right? Because I think this is going to really hit home my point. So if this was a case and then it turned on, right? We're at 25 seconds for both. I'm gonna reset this. Okay. Now we only have one motor going. This motor is not running. So we're gonna look at what the time is, and I'm gonna show you how dramatically different it is if one of your heads dies. And so the powerful part of this strategy is that all you really have to do is like listen to the noise. So if the noise is different, because this is extremely conspicuous when it's running, but if you're just like, man, that thing sounds like it's making more noise, then you can know that there's actually a problem. Like, hey, that thing is never running or it's never turning off. See, right now, boom, we're almost at 40 seconds, right? So it's gonna probably take about double. Like if I was to expect, it's going to take probably about 50 seconds because that's 2 times 25. All right, so how about that? 50 seconds because that's 2 times 25. So the way the unit works is each motor is producing air to pump up the tank, and they work as a team. But if there's a leak or if there's a problem, then your compressor's compromised. Now the reason this matters is because if that one dies and you don't deal with it, that one is gonna die because it is it's doing all the work that both of them should do, and you might be happily practicing dentistry, but eventually that one's gonna fail. So this is how you can check if your unit's working. Another thing is, in the beginning I talked about the warmth. If I touch that one, okay, that head is now warm. It's not burning me. They can burn you, so be careful. But the heads, if you touch them, they're both warm. So I can tell that they're not cold like they were when they came in here. And so I'm gonna go ahead and turn this back on, and then I'm gonna do a final check, which is gonna be taking it down to 85. Now, whenever you work on something, you wanna make sure you check it a couple times. I'm about 45 minutes away from my shop, so I don't wanna just like run away from this equipment without testing it thoroughly, which I have, and that is part of the repair. So I'm gonna go ahead and okay, that's beautiful. Okay, both my motors are running. Now this little cap right here, this just goes on here, and then this just turns on. So I'm going to just let's see how my single-handedness is here. All right, so there we go. That seemed really good. Oh, there we go. So now this little nut just turns, and that's what reveals that little cap right there. If you ever have a compressor that doesn't have that, it's dangerous. So if you always want to make sure your compressor has a covering of that. So I'm gonna get this back together. Right now this compressor is good to go. I might do, we have a maintenance kit. We might go ahead and do a little maintenance on this one in this next segment. I need to go ahead and touch base with my client, let him know that thankfully his compressor is good to go, and that really at this point all we need to do is just maintain it. And that is, guys, that's really good news, and that's what this channel is about. Let's teach you guys some good stuff you need to know about your equipment, and let's show you that everything doesn't necessarily even need a part. Some things you can fix yourself. In this case, this is a really good representation of just how compressors work and what could possibly go wrong.